So what would this look like in an example? So say that you're doing an experiment. You have this epic yoga archer here, and you're going to run an experiment where you're going to change the velocity and you're going to measure the kinetic energy, and you're going to keep mass constant at 1 kilogram. So you're going to pick a velocity, you're going to measure the kinetic energy, and you're going to keep the mass constant. So I got a handy dandy data table here. Let's pick a velocity to test. Let's say our archer, she launches that arrow at 2 meters per second, and we calculate the velocity, or we measure the velocity and figure out how many joules of energy it is. Without running the experiment yet, let's make a prediction using our formula. You guys are going to need to be able to plug and chug numbers. The mass of the arrow is 1 kilogram, so we're going to definitely be using that as one of our knowns. And let's use this equation and just fill it in. So if we know that K equals 1/2 mv squared, we know that K equals 1/2 times the mass, which was 1, times the velocity, which was 2, and we're going to square it. Now if I solve 4 times 1 times 1/2, I get 2. So I would fill in that. Let's just make this smaller, put it there, because I'm going to do another calculation. Okay. Let's double the velocity and see what happens to kinetic energy. Have you figured out any predictions of what might happen to kinetic energy? Just knowing what we know about the relationship between velocity and kinetic energy. Let's throw it in the formula and see if our prediction is correct. So if kinetic energy equals 1/2 times the mass, which was constant at 1, times 4 meters per second, and we're going to square it, then as we complete this calculation, times 1 times 4 squared is 16. 16 times 1 is 16, divided by 2 equals 8. Equals 8. It's going to be joules because that's our units of energy. We can easily see what happened here. Kinetic energy was multiplied by 4. So we quickly see this relationship, and we can make all the we can almost fill in a huge data table just following this pattern. If we double the velocity, we're going to quadruple the kinetic energy. Easy peasy lemon squeezy. So that tells us more about that square relationship, and in this video, I hope, helps us calculate kinetic energy given a velocity and a mass. All right. Good luck, team.